Properties of benzene. In general, benzene is a unsaturated compound. It has three double bonds. Generally, unsaturated compounds are undergo addition reactions, but benzene is an aromatic compound. Benzene undergo electrophilic substitution reactions because of its aromaticity, and benzene is a electron rich compound. It donates electrons towards electrophiles and participated electrophilic substitution reactions in which the resonance stabilized aromatic ring system is preserved. General electrophilic substitution reaction. Benzene reacts with a compound. One of the hydrogen is substituted with electrophile and forms a electrophile substituted benzene. This reaction proceeds to three steps. The first step is called as generation of electrophile. The second step is called as sigma complex, and the third step is called as removal of proton or product 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 formation. In the first step, the reagent ionizes to form a electrophile, and the second step, the electrophile attack on benzene ring. The formation of intermediate is known as sigma complex. Here, benzene is an electron-rich compound. Benzene donates electrons to the electrophile and forms a carbonium ion. These carbonium ion undergo resonance structures like this. This carbonium ion undergo resonance structures. These resonance structures are called sigma complex. This is the hybrid of resonance structure. This step is called as a rate determining step or DS step. The third step is called as removal of proton or product formation. In this third step, loss of proton and regenerates the aromatic ring and gives the product. Here, where the electrophile is attached, that carbon loss of proton and forms the product. These are the three steps for electrophilic substitution reactions in benzene. Now, the first reaction is a nitration reaction. Nitration. Benzene reacts with hot and concentrate HNO3 in the presence of concentrate H2SO4 to give nitrobenzene. This reaction is called as nitration reactions. Concentrate HNO3 and concentrate H2SO4 is called as nitrating mixture. Benzene in the presence of concentrate HNO3 and concentrate H2SO4 give nitrobenzene. Nitrobenzene. This is nitration reaction. This reaction is also proceeds to three steps. In the first step, formation of electrophile. In concentrate HNO3 and concentrate H2SO4, these two on reaction to give electrophile NO2 plus and H3O plus and 2HSO4 minus. In nitration reaction, NO2 plus is a electrophile. The second step, the sigma complex, formation of sigma complex. Benzene donates electrons to electrophile NO2 plus and form a carbonium ion. This carbonium ion forms resonance structures. These resonance structures are called as sigma complex. This is NO2 resonance hybrid of nitrobenzene. Resonance hybrid structure of the sigma complexes. The third step, product formation or removal of proton. Here, the hydrogen loss of hydrogen from benzene ring where the nitro group is attached. This the product is nitrobenzene in the presence of HSO4 minus. Here, loss of proton and the aromatic character of the benzene ring is retained. This is NO2 in nitrobenzene. This is nitration reaction. In this nitration reaction, NO2 plus is a electrophile. NO2 plus is electrophile. The next halogenation or chlorination reaction. Benzene reacts with chlorine in the presence of Lewis acids to give chlorobenzene. This reaction is called chlorination reaction. Benzene reacts with chlorine in the presence of Lewis acids give chlorobenzene. This is called chlorination reaction. In general, Lewis acids are AlCl3, FeCl3, BF3. In general, Lewis acids are AlCl3, FeCl3, BF3. Benzene reacts with chlorine in the presence of Lewis acid gives chlorobenzene. Chlorobenzene. This reaction is also have three-step mechanism. In the first step, formation of electrophile. In the presence of Lewis acid, chlorine undergo ionization to form Cl plus and FeCl4 minus. In this reaction, Cl plus is a electrophile. Cl plus is electrophile. The second step, sigma complex. Benzene donates electrons to the Cl plus. Benzene donate electrons to electrophile Cl plus and here the carbonium ion is formed. This carbonium ion undergo resonance structures. These resonance structures are called sigma complex and this is the resonance hybrid structure. The next one, product formation. Removal of proton from the benzene ring and it forms the chlorobenzene and FeCl3 in the presence of FeCl4 minus base. The aromaticity of benzene is retained. In chlorination reaction, chlorine is a electrophile, or you can if you can take bromine instead of chlorine, you can take bromine. That reaction is called as bromination reactions. In general, these reactions are called halogenation reactions. Halogenation reactions. For example, if you can take a benzene a reaction with halogens in the presence of Lewis acids, it will give halobenzene. Halobenzene. This reaction is called as halogenation. Halobenzene. Halobenzenes. The next one is sulfonation reaction. Sulfonation. Benzene reacts with sulfuric acid at 80 degrees centigrade temperature to form benzene sulfonic acid. This reaction is called as sulfonation reaction. Benzene reacts with sulfuric acid at 80 degrees centigrade temperature. It will give benzene sulfonic acid. This reaction is called as sulfonation reaction. In this reaction, the reaction mechanisms follows three steps. The first step is called as what is that electrophile formation. Here, sulfuric acid ionization to form SO3 plus H3O plus and HSO4 minus. In this reaction, sulfur trioxide is act as a electrophile. Sulfur trioxide is act as electrophile. This electrophile is a neutral electrophile. In this sulfur trioxide, for example, if oxygen is double bond O and double bond O. This type of resonance structures also possible. We can write, for example, this is one resonance structure. Then next you can write also S double bond O and O minus plus double bond O. For example, electrons is oxygen. For example, S double bond O, S double bond O, O minus plus. Here is the sulfur trioxide is a electrophile, neutral electrophile. The sulfur trioxide is also having this type of resonance structures. The second step is sigma complex. Benzene donates electrons to the sulfur trioxide, the neutral electrophile, and form a carbonium ion. This carbonium ion undergo resonance and form a sigma complex. Here, the resonance hybrid structure of sulfur. Next, removal of product formation and removal of proton where the sulfur trioxide is attached, where the electrophile is attached. That carbon donates or loses proton and retain the aromaticity of benzene ring and form benzene sulfonic acid. Hmm. The next one, Friedel-Crafts alkylation reactions. In Friedel-Crafts alkylation reaction, benzene reacts with alkyl halides in the presence of Lewis acids to form alkyl benzenes. Benzene reacts with alkyl halides in the presence of Lewis acids to form alkyl benzene. Here, the Lewis acids are AlCl3, FeCl3, BF3, in general Lewis acids. Benzene reacts with alkyl halides in the presence of Lewis acid will give alkyl benzene. This is also a three-step mechanism. This is also having three-step mechanism. In the first step, electrophile formation. Alkyl halides in the presence of Lewis acids will give carbonium ion R plus and AlX4 minus. This is the electrophile. Alkyl carbonium ion is a electrophile. The second step, formation of sigma complex. Here, benzene donates electrons to the electrophile and form carbonium ion. This carbonium ion undergo resonance structures and form a sigma complex and valence hybrid. The third step, product formation. Here, loss of proton in the presence of AlX4 minus base and loss of proton from the carbon attached where the electrophile is attached. That carbon loss the proton and give the final product alkyl benzene and AlCl3. This is the general reaction of alkyl benzene. If you can take here or in this reaction, R means alkyl group. R is equal to alkyl alkyl groups. For example, you can take methyl chloride. For example, you can take methyl chloride, you will get the taurine, you will get taurine. For example, you can take propyl chloride, cumin, isopropyl benzene, or cumin is the product. Here, R is a alkyl group. You can take any alkyl halides. The next one, Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction means the benzene reacts with acyl chloride benzene reacts with acyl chlorides in the presence of Lewis acids give acyl benzenes or acetyl benzene. Acyl benzene. Benzene reacts with acid chlorides or acyl chloride or COCl acyl chloride or acid chloride in the presence of Lewis acid AlCl3 is form acyl benzene. This is also a three-step mechanism. First step, electrophile formation. Acyl chlorides in the presence of Lewis acids, it will give a carbocation, carbonyl carbocation. This is a electrophile. Benzene in the second step, sigma complex formation. Here, benzene donates electrons to this carbonyl carbon and form a carbonium ion. This carbonium ion form a sigma complex and resonance hybrid. Final product formation here the loss of proton and form a final product and HCl. For example, if you can take here also R means alkyl groups or means alkyl groups. Acetyl chloride, for example, I am taking acetyl chloride. Benzene on reaction with acetyl chloride in the presence of Lewis acid, it will give acetophenone and HCl. Acetophenone and HCl. These are the some of the reactions of benzene electrophilic substitution reactions. Thank you very much.